Hello everyone. In this video we are going to discuss about another data structure concept called queue. Logically, a queue is a FIFO structure. That means it uses the first in first out logic, where if we take an example of people standing in a queue, the first person enters the queue will be the first person to come out of the queue. Same like that, if you have a set of elements, the first element which has been inserted will be the first element which will be deleted. So same like that, it can physically be implemented either as an array or as a linked list. Same like stack, which can be used as an array as well as a linked list. Queue also can be implemented either as an array or as a linked list. So whatever implementation it is, the insertion takes place at the rear end and the deletion takes place at the front end. So this is the difference between stack and queue. So in stack, both insertion and deletion will be done at the top, that we call it as push and pop. But here in queue, the insertion will be taken place at one end, that is rear end, and the deletion will take place at the front end. Now we are going to see queue as an array. So that is the first concept. When a queue is created as an array, its space required is declared before process, that is it is predetermined. So you have to know how many maximum elements can be stored in an array, and you have to declare it in the beginning itself. The beginning of the array becomes its front end. So the first element, so whichever you insert will be the front end. It will go to the front end, and as you insert the element, it will be inserted through the rear, and that will become the end of the array once it is full. Now we are going to see insertion of an array queue. So consider an array queue with n elements. So we are going to consider of an array which has n elements. So the subscript values will be 0 to n minus 1. Okay, and now the at the beginning front value and rear value is declared as null. That means it does not have any value. Okay, both are empty. Now once you enter the first value, both the front and rear becomes 0. That is, both are facing the same point. Okay, so front value will have one element. Same way, rear also will be pointing to the same thing. As you keep on increasing, that is, as you insert the elements in the queue, you can notice that front value will be the same. Increase the value of rear. That means the rear will be moving towards its right as you include, that is, insert more elements on the queue. That means the rear value will be reaching n minus 1. So it goes on till n minus 1 so that the queue becomes full. So till that, rear value alone will be moving. So that is the indication whether the stack is empty or how many elements are available, as well as whether it is full. Now same way, deletion in an array queue is done from the front. That is, deletion can occur at the front only. So at the beginning, you have some 4 values here, that is subscript values for the elements given is 0 to 3. So front value will be 0 and rear value is 3. That means you have 4 elements. Okay, that is indication. As you delete, so the first element will be deleted. Okay, so once the first element is deleted, the front value will be moved more towards its right. That is, it becomes 1. So front value becomes 1 and rear value is same as 3. So once you insert, rear value will change. Once you delete, front value is changing. So you can see the next example again. Another element has been deleted, so the front value will be moved from 1 to 2. So front value is 2 and then rear value is 3. So when you know it is empty, so when it meets front and rear meets at the say for example 3. Okay, when it goes beyond that, then you know that the queue is it's empty, and so that you can display a message that it is the elements all have been deleted. Same way, you can also implement linked queues. So linked queues are the queues having links among its elements. So you already discussed in the stack how the nodes will look like. Okay, so you will be creating node by node. Okay, so you can create nodes so that it will point to the next node. So if you have 3 nodes here, you can see that you will have a pointer. The pointer will be pointing to the first node, that is the front. And you can see another pointer which will be used as rear, which will be pointing to the last node. Okay, this is what the difference between stack and queue. In stack you will have only top, which will be pointing to the first node, but here you have 2 pointers. One will be pointing to the first node, that is front, and rear will be pointing to the last node. So as you insert and delete, this will change. Now insertion in a linked queue. So what is happening here is the insertion in linked queue always takes place at the rear end. That's what we just now saw it in the arrays concept also. Here in linked you can see that once you insert something, rear value is being modified. Okay, so rear value gets modified with every insert. Now old link is been the which is pointing, the rear pointer is pointing to the old link. Once you insert a new element or new node, you can see that rear, that is the pointer which will be pointing to the new link, that is the next node. Okay, so that is the difference. So this rear pointer has been modified. Next is deletion. So deletion in link queue also takes place in the front end. So from the beginning, that is from the front of the queue. The front get modified with every delete. So once you delete, say this is the old link which is pointing. Okay, the front pointer is pointing to the first node. Once you delete the first node, automatically the pointer will be pointing to the new link, that is the second node. So it automatically modifies the front pointer. Okay, this is how the deletion occurs. So this is a concept we were discussing. Okay, hope you understood this concept. We will see some programs so that you will understand more. It will be more clear. Okay, so till then, thank you.